2007 was the first year to start using the Java docs notation that I could find. I put a post yesterday in my Google Classroom with a link to Java docs, just like an intro. Really, it's just a way to format your comments and other aspects of your code. I've never emphasized it because it's not something we are required to do. So you could think of like in your English class learning about like MLA format. But like I said, we're not required to use Java docs notation. If you want to read about it, that's great. The College Board will use it in their code. So as we look at the questions from 2007 forward, we'll notice that the comments on methods are all written in a kind of a peculiar way. So you're going to see like this sort of extra asterisk in their block rems. You're going to see things like @param to label arguments, parameters within method calls, and you're going to see @return in a return method. And we're also going to notice a lot of the use of the words precondition and postcondition. A precondition is just a given. Never question it. Accept it as fact. If they say precondition number greater than 0, and in your code you write if number greater than 0, well, I don't think then that you really understand what a precondition is. Okay, they're telling us that the number is greater than 0, so there's no reason for us to ask if it is. It's been given as fact. We should just accept it and not worry about any counter cases to it. Postconditions can be a little bit trickier. Postcondition means like at the end of the method call, maybe the state of the array needs to be unchanged, or the order needs to be in a certain way. So it's like something that has to come out of it. And then that's something that I don't see in this particular question, but we'll discuss when we come up to one that we do see some postconditions. So back to this problem here. This is from 2007. First question dealt with self-divisor. There's actually some really good Java coding bats on this one too. If you go to the AP1 section, I think it's called divide self. Just change the name a little bit. So a self-divisor is any number whose digits can all divide evenly into the number. So 128 is a self-divisor because 1, 2, and 8 all divide evenly, meaning no remainder, into 128. 26 is not a self-divisor because 26 is not divisible by 6. And very important note here says 0 is considered never to be a divisor of any number. So if there's a 0, get rid of it. Now, what they didn't point out to you there, and they're kind of setting you up for it, is just like we can't divide by 0 in Java, we also can't modulus by 0. We'll get a strange runtime error if we do. So it's important that we'll actually prevent our code from ever allowing the modulus by 0. If we don't prevent that, we're going to get a crash during runtime, which guaranteed you're going to lose points on your AP question if you have any code that produces a crash. So we'll need to prevent any modulus by 0, just like we need to prevent divisions by 0 as well. And then in part B, they give us a start value and a number, and then starting at start, we have to produce a certain number of self-divisors and place them into an array that gets returned. And we'll have to call our method from part A when we write part B, or else, this is another case where we lose points for not following directions. So is self-divisor, doesn't, we're just handed a copy of this int, so I don't really see any reason like why we couldn't destroy it. However, we will need to preserve the number so that we can keep checking back on it as we perform more and more divisions, right? Like the original number has to be divisible by its first digit and its second digit and its third digit. So if we're going to destroy the number through a modulus 10 divide by 10 scheme, we need to keep a copy of the original so that we never lose it. So now let's say that we take the number and start dividing by 10. We're going to keep running this while loop then until we hit 0. So while the number is greater than 0, okay, we could pull off some sort of like last digit. Okay, so our last digit would be the numbers modulus by 10, right? If that number is not 0, okay, right? Remember, if this number is 0, we get out of here. So if last digit is not 0, so let's short circuit, okay? And the copy of last digit is equal to 0. Well, let's think about it this way, right? Are we looking for true or are we looking for falses? So if last digit is 0, okay, right? Or we come across a case where copy divided by last digit is not 0, then I think we could immediately return false, okay? If we find one counter case, then we know it's not a self-divisor. And then at that point, what we would want to do is we would want to chop off the last digit from this number. So we could do like a divide equals 10. So each time through, we're going to lose one digit from the end of the number. We're going to isolate the last digit of the number. As long as it's not a 0, we can go ahead and run this. Remember how the short circuit works. If this is true, there's no reason to check the right side of the OR. We would just immediately return false. Remember, self-divisors are not allowed to have zeros as digits. So the only way I get to the right half of this OR is if that last digit is not a 0. So if it's not a 0, I can safely modulus by that digit. If copies modulus by last digit is not 0, then it's not a self-divisor because there's a remainder. I can immediately return false. However, if I don't go through that if statement and I don't return false, I'll go ahead and chop the last digit off from the number, and I'll let the while loop proceed and go on to the next one. And so let's see if we find some self-divisors here. So I got 2 trues and 3 falses, looks perfect. It didn't get confused by like the 0 and 102 or anything like that. Okay, so moving on to part B, like I said, we're definitely going to want to call this method here. This local method is self-divisor. We're writing within the same class. So in this problem, we're supposed to return an array. They did not hand me an array. So I'm going to, first of all, make this array. It's an array of ints, and num is how many of these numbers that we want, okay? And then later, we're going to return this array. In the middle, we're going to fill it. So you could do various types of loops here. I mean, we could write a while loop where we only progress as we find values. I guess things like that. I don't know how you want to do it, but let's say that we made up an index. We started at 0, and we could run this while our index is less than num. Or you could do self.length, should be the same thing. Okay. And so what we'll do is we'll send this number in start into the method from part A. Is it a self-divisor? If it isn't, we'd want to go on and try the next number. So So if that's true, then I'm going to do an action here where I'm going to add that into my array. So selfs at index picks up this value start, okay? And then at that point, I'd want to do 2 things. I'd want to progress start, and I'd also want to progress the index. The real important one here is that I progress the index, so that I go on to the next one. Really, regardless of what happens within that operation, I want to advance to the next value, start either way. So like if I put in a number like 11 and it's a self-divisor, then I want to go to 12. Then I want to go to 13 and so on and so on. As index progresses, eventually we're going to fill this array with values, and we'll get stuck there. And it looks like I misspelled something. I forgot to put the word is, sorry. Is self-divisor. Okay, let's see. And yeah, so we got 11, 12, and 15. So I said start at 11 or 10 maybe and give me 3. And then on this one, I think I started at 500 and I said give me the first 5. And it looks like it found the correct first 5 self-divisors. Okay. Obviously, there's other ways you could write this. If you're scared of while loops, you don't need a while loop. But I like the while loop here because it gave me the freedom to progress the index as I saw fit. So that's why I kind of liked using a while loop here as opposed to a for loop with like a rigid step expression. I only wanted to advance the index as I inserted numbers into the array. However, regardless of whether or not the number was a self-divisor, I always wanted to go on to the next value to run my next test. So that was my logic of writing a while loop with this structure in part B. Okay, so let me know if you got any questions, but hopefully this cleared them up.